Welcome to Endless Learning Training Series, the membrane-based desalination technology.
In this video we will study about the following: cavitation, flashing, choked flow, vapor pressure, difference between cavitation and boiling. What is cavitation? Cavitation is the formation of vapor-filled cavities or bubbles in a liquid, typically caused by a rapid change in pressure. These bubbles can form when the pressure in a liquid drops below the vapor pressure of the liquid, causing it to boil and create vapor-filled bubbles. Vapor pressure, cavitation occur in a liquid flow is characterized by a phase change from liquid to vapor at almost constant temperature. In the pressure/temperature chart of the fluid schematically shown in figure, cavitation can occur in various systems. It can cause damage to the equipment due to the intense forces generated by the collapsing bubbles, which can erode and pit the surface of the equipment. Cavitation of control valve. Cavitation can occur in control valves when the liquid flowing through the valve experiences a drop in pressure, causing bubbles to form in the liquid. The formation of bubbles in the liquid can lead to the collapse of the bubbles, resulting in intense local pressure waves that can cause erosion and damage to the valve and other downstream components. Control valves are typically used to regulate the flow of liquid or gas in a system, and cavitation can have a significant impact on the valve's performance and the overall system efficiency. The severity of cavitation in control valves can depend on factors such as the liquid flow rate, pressure drop, and valve design. When process liquid flow through control valve where P1 is inlet pressure, and P2 is outlet pressure, when a liquid is subjected to a drop in pressure, then liquid quickly change state from liquid to vapor and produce bubbles, then it change from vapor to liquid state when pressure increases above vapor pressure, which cause erosion and damage to the valve. What is flashing? Flashing is a term used to describe a process in which a liquid quickly vaporizes due to a sudden drop in pressure or an increase in temperature. When a liquid is subjected to a drop in pressure, the vapor pressure of the liquid may become greater than the pressure of the surrounding environment, causing the liquid to boil and produce vapor bubbles. Flashing can occur in a number of systems, such as pipelines, valves, and heat exchangers, and can have a significant impact on the performance and efficiency of these systems. The sudden vaporization of the liquid can cause a decrease in the flow rate, as the vapor bubbles take up more space than the liquid, reducing the system's ability to move the fluid through the pipeline or valve. When process liquid flow through control valve where P1 is inlet pressure, and P2 is outlet pressure, when a liquid is subjected to a drop in pressure, then liquid quickly change status from liquid to vapor and produce bubbles. If P2 outlet pressure remain below vapor pressure, then continuous flashing is occur which control significant impact. There are two main types of cavitation that can occur in control valves: incipient, choked flow cavitation. Incipient cavitation. Incipient cavitation occurs when the pressure drops below the vapor pressure of the liquid, causing small bubbles to form in the liquid. As the liquid flows through the valve, the bubbles collapse, creating intense pressure waves that can cause erosion and damage to the valve and other downstream components. This type of cavitation can be identified by the noise produced by the collapsing bubbles, which sounds like a cracking or popping sound. What is choked flow? Choked flow is defined as the point at which increasing the pressure drop, dP, while maintaining a constant inlet pressure, P1, yields no further increase in flow rate. At this point, the flow rate cannot increase even if the pressure drop across the system continues to increase. Choked flow cavitation occurs when the pressure drop across the valve is so high that the flow rate through the valve reaches the maximum possible flow rate for the given conditions, known as the choked flow rate. The velocity of the fluid increases to the speed of sound, and the pressure drops to the vapor pressure of the liquid, causing the liquid to vaporize completely. The resulting vapor bubbles are large and collapse violently when they reach regions of higher pressure downstream of the valve. Choked flow cavitation can cause severe damage to the valve and downstream components due to the high velocity and impact of the collapsing bubbles. Can be detected by the noise produced by the collapsing bubbles, which is typically louder and more intense than the noise produced by incipient cavitation. Major difference between cavitation and boiling. For boiling, the driving phenomenon for phase change is an increase in temperature, whereas phase change is caused by pressure reduction in the case of cavitation.
Thank you for watching this video.